Hi everyone. Welcome to my channel, Maths Made Easy with Terry in 10 minutes. Please, like I said, don't forget to like and subscribe so that you get notifications when I post new videos. Okay, so today I'm going to talk about integration of trig functions. Okay, and there are two ways I'm going to talk about it: powers of sin x and cos x, and product of sin x and cos x. Okay, I'm going to talk about. I'm going to pick like 3 questions to solve here, and hopefully it will make more sense when I'm done. Okay. So the first question I have here, I'm going to work on powers of sin x. The next video is going to be talking about the product of sin x and cos x. All right. So let's say we have sin squared x. There's so many ways to solve this. You can decide to use any of the previous method, maybe substitution to play around with it, or some people might want to try product rule. If you want to look at it that way, it might work out. But in this video, I want to use the trig identities, okay? I want to use the trig identities here. And one of the trig identities I want to use here, you know that I told you before that cos 2x is equal to 1 minus 2 sine squared x, okay? It's one of the trig identities, okay? If you've not watched my videos on trig identities, you can go back and watch videos on trig identities, and you can play around with them. So this is it. So from this trig identity I have here, I'm going to make sine squared x the subject of the formula. So it's going to be 2 sine squared x. 2 sine squared x is going to be equal to take cos x to the other side. 1 minus cos what? 2x. So we divide both sides by 2. Okay, so we now have that sine squared x is going to be 1 over 2 into bracket 1 minus cos what? 2x. So with that now, I can go straight and substitute it here. So that means sine squared x is the same thing as that. So I can say that means we're integrating 1 over 2 into bracket 1 minus cos 2x. Okay, we'll bring out the constant. So it'll be 1 over 2, we're integrating 1 minus cos what? 2x. Okay, now we'll do that. So 1 over 2, when you integrate 1, is going to give you x. Now, in the previous video, I also explained to you that this sign here, so when you integrate cosine, is going to give you sine. That making sense? So that means it's going to give you x minus sine 2x over 2 plus c, okay? So I've talked about how to integrate this before, okay? So just go back and have a look at this, okay? Please look at the previous video so you can understand. So you open the brackets, it's going to be 1 over 2x minus sine 2x over 4 plus c. And this is the answer for this. All right, let me do the same thing for cosine, okay? Let's say I'm solving cosine. I'm going to use the same trig identity here, because I know that the trig identity that we have is that cos 2x is going to be equal to 2 cos squared x minus 1. Do you remember this? Okay. So it's similar to the sine squared x plus cos squared x is equal to 1. Does that make sense? So, but the cos 2x is equal to 2 cos squared x minus 1. Then we'll make cos 2x, cos squared x the solution of the formula. So you take 1 to the other side. So it's going to be 2 cos squared x. It's going to be equal to, take that, it will be cos 2x plus 1. Divide both sides by 2. Okay, so it's going to give you cos squared x will be equal to 1 over 2 cos 2x plus 1. All right, so that means I can substitute all this cos squared x with 1 over 2 cos 2x plus 1. So it's going to be integrating 1 over 2 cos 2x plus 1. I bring out the constant, to be 1 over 2, and I'm integrating cos 2x plus 1. Okay, so 1 over 2. So remember I told you sine is going to give you sine cos minus cos. Once you integrate, what do you call it, cos, it's going to give you what? Sine. So that is going to give you sine 2x divided by 2 plus x. You open the bracket, it's going to give you sine 2x divided by what? 4 plus x over 2 plus C. And that is the answer for this. Okay? So I'm going to just play maybe solve one more question with cube. Okay? I will solve one question with cube. All right? So let's see. So we have sine cube x, okay? Sine cube x. So what is going to give you for sine cube x is the same thing as saying that we are multiplying sine squared x multiplied by sine x. Is that okay? Now, but you know that from trig identity, sine squared x plus cos squared x is equal to 1, okay? So that means if I know that this is equal to 1, then I can now play around with the question and just say, okay, making sine squared x the subject of the formula, it will now become 1 minus cos squared x. So that means I'm going to take this to the other side. So it's going to be, so therefore I can now say my sine squared x is equal to 1 minus what? Cos squared x. So that means I can now play around and put this in a question that is going to be 1 minus cos squared x multiplied by what? Sine x. So basically, I substituted the sine squared x with 1 minus cos squared x. Then the next thing, I'm going to open the bracket. Sine x times 1 will give me sine x. This will give me minus integrating cos squared x sine x. Okay? So then, as usual, I've talked about the product rule before. I've talked about how to work with integrating products. So I want you to take this as an example, okay? I want to finish it up. And you can solve that yourself. But the final answer you should get, it should be minus cos x plus cos cube x divided by 3 plus c, okay? Now, try and solve it, okay? If you did not get it, let me know. Then I'm going to make a video to show you how to get it. But you should be able to do this because I've had a video already on solving with product rules, especially for trigonometric function. Okay, so you can use integration of products for trigonometric functions. Okay, so have a look at it and have a go at this question, and you see you get the same answer like that. All right. Okay, so that will give me that for that. So the next video I'll be talking about will be product of sine and cosine, all right? And please don't forget to like and subscribe. And if you don't have any question, please put it in the comment section and I will see how to solve it for you. All right, thank you very much. And I'll see you in the last video for this series.